Hello students, most welcome in the first lecture of integral calculus. So in this lecture I will discuss some preliminary of the integration for the syllabus. Okay, so let's start. तो यहाँ पर हमारे पास we know that the derivative, if you are taking derivative of a capital fx function, you will get a small fx function, and when you integrate this fx with respect to x, you will get capital fx again. Okay, so this shows that integration is the inverse process of differentiation. Okay, so we know this in our earlier classes, we have read these all things. Okay, so if we just integrate this fx, you will get capital fx plus c. So c is the called the uh, constant of integration, because if we differentiate this constant function, हम अगर constant को differentiate करते हैं we will zero. तो we know that if you are differentiate this fx, you will get small fx. Oh, if you are differentiating this capital fx plus c, you will again get small fx. Okay, so if you are simply integrating this small fx, you must have to add some constant, and that constant depending on the curve and at all. Okay, so this type of integration is called indefinite integral. Okay, this is called a indefinite integral. Okay, and if we have setting some boundary, like this is a to b, and this is fx, okay, of dx, and you are integrating, this is fx plus c, and you are applying these limits a to b, then you have this is fv plus c and minus of f a plus of c. So from here you get this is fv minus fa simply. So there is no need of this constant. Okay. So this is type called is finite integration. This is called finite integration. This is called finite integration. Okay. So as we know that, then एंड हमारे पास जब हम इंटीग्रल्स कैलकुलेट कर रहे होते थे तो बहुत सारे मेथड होते थे, सब्स्टिट्यूशन मेथड, इंटीग्रेशन बाय पार्ट्स एंड एट ऑल. Okay, so we have some formulas. First formula, we know the integration by parts is what? Integration by parts. So you just remember this formula. So here, if we have to integrate some two functions, एक f1x and another is f2x. Okay, then we just put f1x as it, and find the integration of the second function. Okay, and minus the integration, and this is the bracket derivative of the first function and integration of the second function, then whole integration, and then something constant will be there. Okay, so this is called the integration by parts. So this is integral सम प्रोडक्ट फंक्शंस है ना. और मुझे पता होता था कि हम किसको फर्स्ट फंक्शन मानना है, किसको सेकंड फंक्शन मानना है. तो हम एक रूल पढ़ते थे, आइलेट. तो जस्ट रिमेंबर दिस रूल. आइलेट मीन्स इनवर्स ट्रिग्नोमेट्रिक फंक्शन, एल मीन्स logarithmic function, a for algebraic function, t for trigonometric function, e for exponential function. ओके, तो अगर हमें ऐसा कुछ ऑर्डर मिलता है फंक्शन का, तो जो पहले पढ़ रहा है, जो पहले लेटर पढ़ रहा है, उस फंक्शन को हम फर्स्ट फंक्शन मानते थे. ठीक है, तो ये सारी चीजें हम लोग जानते हैं. हम बस फटाफट इनको रिवाइज कर दे रहे हैं ताकि हमें डिफिकल्टी ना हो. जो हमारे पास अपकमिंग सिलेबस का कंटेंट हम पढ़ेंगे तो उसमें हमें डिफिकल्टी ना हो. और आपको भी मैं सजेस्ट करता हूं कि जस्ट गो एंड रीड योर बुक ऑफ द फर्स्ट चैप्टर, है ना. दैट विल बी रिकॉल ऑल योर द mathematics of integration which you have studied in your 12th standard. Okay, so just read, you can able to revise by self as well. Okay, so I'm going to write some formulas, and you just remember and also jot down that formulas for you. Okay, so some standard formulas. I'm also, these are written in your textbook, but also I'm going to write one by one and explain as well. Okay, so it's some standard formulas. So I'm just changing the color. Okay, so first one, that is very important formula, and we should know the integration of ax plus b the power n of dx is what. This is, we know that this is your 1 by a. What is the coefficient of x? That will become in denominator, and this is your ax plus b power n plus 1. One power will be raised and upon n plus, where this n should not equals to minus 1. Okay, so what will happen when this n is just equal to minus 1? Then the logarithmic formula will appear. So this is ax plus b power minus 1. It will becomes equals to, this is 1 upon a, and this is your log of ax plus b. And here we are writing the formulas for the indefinite integral. We are not here the indefinite definite integral. It's an indefinite integral. We just adding c here as a constant. Okay. Second formula is what? Integration of e to power ax dx is just equal to 1 upon a e to power ax and plus some constant c. Number third, integration of a to power bx plus c. So I'm just writing bx plus k because we are using c as a integration constant. Okay, so this is bx plus c will equals to here a to power bx plus k. Okay, and in the pawn this is b, and this is to the base e log a, and plus some constant c, and this a not taken to be 1. Okay, so thus you remember this formula. Okay, next fourth number formula is what? The integration of sine ax plus b of dx. Okay, so it will be equals to minus 1 upon a cos of ax plus b and plus some constant c. And in the fifth number problem, the formula, this is cos of ax plus b. So we know that the derivative of cos x is minus sin x, then it means the integration. So it is easy to remember this formula. You should remember the derivative formulas. Okay, what will be the derivative? So you can just take a reverse process, and the inverse you can say. So cos ax plus b plus dx is just equal to 1 upon a sine of ax plus b and plus some constant c. Okay, 6. The integration of tan ax plus b of dx is just equal to 1 upon a log sec of ax plus b plus c. एक चीज ध्यान रखना, तो coefficient of x always comes in the denominator. You can just remember this thing. Seventh number formula, this integration of cot ax plus b of dx is just equal to 1 upon a log of sine of ax plus b plus of c. Then eighth number formula is integration of sec square of ax plus b of dx is just equal to 1 upon a. This is tan of ax plus b plus of c. Because we know that the derivative of the tan x is sec square x. So integration of sec square x will be 10x again. The ninth number, the integration of the cos sec square of ax plus b of dx is just equal to minus 1 upon a cot of ax plus b and plus some constant c. And then 10th number formula, I'm just writing all the formulas also written in your textbook. If you have the textbook, you can also went through that, gone through that. Okay, so sec of integration of sec of ax plus b and tan ax plus b of dx is just equal to 1 upon a sec of ax plus b and plus of some constant c. I'm just writing the 11th formula, that is your cos sec ax plus b cot ax plus b dx is just equal to minus 1 upon a cos sec ax plus b plus c. Okay. Next, formula number 12. So here the integration of this cos sec, this is your ax plus b of dx is just equal to 1 upon a log tan, and this is your 1 by 2 ax plus b and plus some constant c. Okay. You should be understood that in every indefinite integral we should have to add the this c. Okay, this integration constant. So this is sec of ax plus b of dx is just equal to 1 upon a log, this is your sec ax plus b plus tan ax plus b. Okay. 14th number problem. The integration of sine hyperbolic, then hyperbolic ax plus b of dx is just equal to 1 upon a cos hyperbolic ax plus b plus some constant c. Okay, and then you have integration of cos hyperbolic x is just equal to 1 by a, and this is sine hyperbolic ax plus b. Okay. Sixteen number, this is the integration of tan hyperbolic ax plus b of dx is just equal to 1 upon a log cos hyperbolic ax plus b. Okay. Then the 17th number formula, then integration of cot hyperbolic, this is your ax plus b of dx is just equal to 1 upon a log sine hyperbolic ax plus b and plus some constant c. Okay. In this same way, the 18th number problem, then integration of sec hyperbolic. Sir, hyperbolic square of ax plus b. So it will be equal to 1 upon a tan hyperbolic ax plus b plus of c. Okay. And the 19th is what? That is integration of cosec hyperbolic, and this is your ax plus b of dx is just equal to negative times 1 upon a cot hyperbolic ax plus b. Okay, then we have this 20th formula. So you can just gone through all these formulas. You just read one and by and write by self also. Then you can able to remember this, because without formula you cannot going to integrate any of the function. So this is sec hyperbolic ax plus b, and 10 hyperbolic ax plus b of dx is just equal to 1 upon a sec hyperbolic ax plus b plus of c. 21st, that is integration of cosec hyperbolic ax plus b of d, and this is your cot hyperbolic, this is ax plus b of dx is just equal to minus 1 upon a cosec hyperbolic ax plus b. Okay. Next, 22nd, this is constant c is added. 22nd formula. So the integration of the function root of a square minus x square of is just equal to, because we know that the derivative of sine inverse x is your 1 upon root of 1 minus x square. So in the similar way, the integration of 1 upon root of a square minus x square will equal to sine inverse x upon a plus some constants. 23rd, that is integration of a square plus x square is just equal to 1 upon a tan inverse of x upon a plus c. 24th is integration of dx upon root of a square plus x square is just equal to sine hyperbolic inverse of x upon a plus c. 25th of the 55th formula is integration of dx upon root of x square minus a square is just equal to cos hyperbolic inverse of x upon a plus c. Okay. Next, 26th formula, that is equals to integration of 1 upon x root of x square minus a square of dx is just equal to this is sec inverse of x upon a, and this is 27th, and that is equals to integration of root of a square minus x square of dx is just equal to x upon 2 root of a square minus x square and plus half of a square, and this is sine inverse of x upon a plus some constant c. Why we are writing all these formulas? Because you will have to write in your copy. Okay, so you just read and write as well together with me. So integration, this is root of a square plus x square of dx is just equal to 1 by 2 x root of a square plus x square plus 1 by 2 of a square sine hyperbolic x upon a plus some constant c. 29th is just this is also some another way of writing this formula. So we are also writing this formula in this way, that is 1.2 x root of a square plus of x square and plus half of a square and log x plus root of x square plus of a square. Okay, so this is also writing this formula in this way. 28th formula. Okay, 29th one, that integration of root of x square minus a square of dx is just equal to 1 by 2 x root of x square minus of a square minus 1 by 2 of a square cos hyperbolic inverse of x upon a plus some constant c. This formula is also written like this. This is 1 by 2 x root of x square minus of a square minus 1 by 2 a square, and this is log of x plus root of x square minus a square plus some constants. Okay, so whatever the formula you just remember, that any one of the formula you should remember. So integration of, if the e to power ax is multiplied with sine of bx plus c of dx, okay, that is equals to e to power ax, okay, what is, and a of sine of bx plus c minus of b cos of bx plus c. Okay, so this thing we have in bracket, and it's divided by your a square plus b square. So this is some constant k should be here, and just take it d as a constant. Okay, because c is already used in this expression, that's why we have just put it at d here. ओके, तो अगर e की पावर ax sin bx plus c में मल्टीप्लाइड है तो दो प्रोडक्ट फंक्शन है, तो डायरेक्टली यू कैन यूज दिस फार्मूला e की पावर ax and a sin bx plus c and minus b cos bx plus c upon a square plus b square. So in the similar way, the 31st formula for the cos one. Okay, so that is your integration of e to power ax plus b cos of bx plus c of dx is just equal to e to power ax, and this is a of cos of bx plus c plus b of sine of bx plus c divided by a square plus b square, okay, plus some constant d. Second formula, the integration of dx upon एक्स स्क्वायर माइनस ए स्क्वायर, इसको हम पार्शियल फ्रैक्शन करके करते हैं, तो वी विल गेट 1/2a log x minus a upon x plus a. When this x is greater than a, then you can just use this formula. When this x is less than, then you just use this formula. This is a minus x upon a plus x when x is lesser than a. Okay, so 32nd 33rd, okay, integration of cos की power n of x dx. This is very important formula, you just remember it. This is 1 upon n sine of x, okay, cos to power n minus 1 of x plus n minus 1 upon n integration of cos to power n minus 2 of x dx. Okay, so you can just gone through and so on. Okay, so this is the integration of cos की power n, and similarly the integration of sine की power n of x of dx. So this will be equal to minus 1 upon n cos of x sine the power n minus 1 of x plus n minus 1 of n. This is integration of sine n minus 2x of dx plus का c. And then integration of tan for nx of dx is equals to 1 upon n minus 1. This is your tan n minus 1 of x means integration of this is tan n minus 2 of x of dx is plus of t. Okay, so you just remember these formulas for the advanced level integration. The integration of this is cot per n of x dx is just equal to 1 upon n minus 1 cot n minus 1 of x minus integration. This is cot n minus 2 x of dx plus of c. So this is integration of sec for n of x dx is just equal to, this is your sec for n minus 2 x tan of x divided by, this is n minus 1 plus n minus 2 upon n minus 1 integration of sec of n minus 2 x of dx plus c. So eighth number formula, this is the last one in your textbook as well. The cosec n of x dx is just equal to cosec n minus 2 x cot of x divided by n minus 1 plus n minus 2 divided by n minus 1. This is integration of cosec n minus 2 x of dx plus of c. Clear? So these are formulas we are know. These are the formulas and very important formulas. So I just wrote it all the formulas. So you can jot down in your notebook as well. Okay. And also for the, so, and next is definite integral. So we already know the definite integral basically calculates the area bounded by the curve. If we are line integration, and again then the volume integration as well. So in the detail we will talk in the chapter, respective chapter for the integration. So for the today we just write all the formulas in this lecture. Okay, and then in the next lecture we start for the definite integrals. Okay, so okay, so next we meet in the next lecture for the definite integral. Okay, so for today it is enough. Thank you so much.